I'm going to do chapters 9.3, 9.4, and 4 separately. So chapter 9.3 is answering questions about the mean of a population and how to construct and interpret a confidence interval for a population mean. Now, emphasis here on confidence interval for population mean. Okay, very important words, how we state what is a confidence interval. There are two approaches for answering questions about a population mean. The first being confidence interval, using or estimating parameter values. And the second, the one that we will do in chapter 9.4, is called hypothesis testing and is used for deciding whether parameter's value is one thing or another. These are the same methods as introduced in the previous chapters for population proportion, but modified to work with population mean. Okay, so instead of using proportion this time, so many successes are out of a total population, we're using population means instead and standard deviation to compute either the confidence interval or the hypothesis test. Confidence interval provides a range of plausible values for the population mean, along with a measure of the uncertainty in our estimate. Again, emphasis on the word population. It is a measure of the uncertainty in our estimate. The higher the level of confidence, the better our estimate is. When to use confidence interval? Use confidence interval whenever you are estimating the value of a population parameter on the basis of a random sample. Do not use the confidence interval if there is no uncertainty in your estimate. If you have data for the entire population, you need to find the confidence interval since the population parameter is no need. There is no need to estimate it. Okay? As usual, the same three conditions must be met to determine confidence interval. One, the sample must be random and independent. Then we must use the large sample for the sample size is at least 25. And the big population the sample must be at least 10 times, the population must be at least 10 times larger than the sample size. Okay, in most cases, those are going to be met. If you want to check, that's up to you some of the time. Here's an example. A used car website wanted to estimate the mean price of a 2012 Nissan Altima. The site gathered data on the random sample of 30 such cars and found a sample mean of 16,000 and a sample standard deviation of 2,036. The 95% confidence interval for the mean cost of this model is based on the data 15,588 to 17,632. In other words, it's saying that, I'm going to go through this in the problem. Let's describe the population. Is the number 16,000 an example of a parameter of a statistic? And verify the conditions for a valid confidence interval are met. So, still with the first question. Is the number 16,610 an example of a parameter or a statistic? Okay. This number 16,610 is a statistic because it's measure of a sample. Okay, they're pulling it from a sample of 30 and not the entire population. So it would be a parameter if it was the whole population. Conditions. Let's look at the conditions. The sample we're told already, is random and independent. The sample size is 30. large, which is at least 25, and the population is 10 times 40 is 400, we can assume that the population for 2012 Nissan Altimas is way more than 400. Okay. Now, that's just checking to see what we understand about it. Now, interpretation of the confidence interval. And pay attention to this. The confidence interval is a measure of how well the method used to produce the confidence interval performs. For example, a 95% confident interval means that if we were to take many random samples of the same size from the population, we expect 95 of them would work, contain the population parameter. Again, emphasis contain the population parameter, and 5 of them would be wrong, not contain the population parameter. Okay, so we're 95% confident that every time we pull a sample, it would work. Only 5% of the samples would not work. All right, now we're going deeper into how to compute this. Data on speed in miles per hour for a random sample of 30 cars traveling on a highway was collected. The mean speed, now the sample is 30, the mean speed is 63.3 miles per hour with a standard deviation of 5.23 miles per hour. Find the 95% confidence interval for the mean of speed of all cars, verify that the necessary conditions are met. So the sample is random and independent. We can assume that the population is large, 10 times 300, and the sample is large because the sample is 30, which is at least 25. So we know the 3 conditions are met. Now, I want to go through how to do this with both StatCrunch and with the calculator. Okay, so let me write down these numbers, and I'm going to go to StatCrunch and show you how to input this data. 63.3 is the mean, standard deviation is 5.23, and the sample size is 30. Okay, and I'm just going to go to the StatCrunch program and show you how to input this into StatCrunch. So I have StatCrunch open here. And we use t-stats. Okay, t-stat, one sample with summary. Type in your sample mean. So the sample mean is 63.3. The standard deviation is 5.23. And the sample size is 30 samples. Okay. Notice that we're selecting confidence interval of 0.95 or 95% in compute. And what we have here is the printout of the I need to snip this and bring it over. It's already there, but I just wanted you to see that we also did it on our own. Okay, this is the calculator printout. Drag this in here. And you can see our numbers pretty much match. Now, right here is the lower limit and the upper limit for the confidence interval. Okay, I'm going to discuss that. The lower limit is 61.35. The upper limit is 65.25. I also want to do this with the calculator And actually, this is one of those cases where it's faster with the calculator. Okay, so let's open up our calculator. Here we go. Calculator. Stat. Test. And select number 8. T interval. We want to do this for data, for stats, and not data, okay? I am sorry, this is not, yeah, this is correct. We're inputting the data, the stats. So we're putting in our, yes, 63.3 is the mean, right? X bar standard deviation is 5.23, N is 30, and the confidence level is 0.95. Enter and ask it to calculate. And there we go. There's the confidence interval, 61.35 and 65.25. So you can see it's probably faster to do it with the calculator in this case than the StatCrunch program, but know that you can use either one, okay? So here it is. This is the calculator printout. So I'm going to use the calculator printout down here as well. Let's put the calculator printout here. Uh-oh. And you can see the calculator printout also shows that the 2 decimal places 61.35 and 65.25. That is the confidence interval. Now, to interpret the meaning of the confidence interval, okay? Here is how you would write this. We are 95% confident that the speed of the cars on the highway is between 61.35 miles per hour and 65.25 miles per hour. Now, that's part C. Is it plausible that the mean speed of cars on the highway is 67? Since 67 is not in this interval, it is not in our interval, it is not plausible, not a plausible value for the mean speed of the cars on the highway. End of the discussion. Okay, you just look to see if the number you given is between 61 and 65, and it's not, so we're out of gas with that. Okay, these are the instructions here for the calculator if you need to do it with the calculator. Okay, all right, let's look at some of these problems. So these are the printout from the homework. A random sample of 12 colleges were taken. The mean graduation rate of graduation within 4 years was 43.6% with a margin of error of 7. The distribution of the population is normal. Complete the parts below. 1. Choose the correct interpretation of the confidence interval below and fill in the answer boxes to complete your choice. So we have a mean of 43.6 and a standard error of 7. The lower limit is 43.6 minus 7.0, which is 36.6, and the upper limit is 43.6 plus 7, which is equal to 50.6. So if we're writing this, we want to say always we are 95% confident that the population mean is between 36.6% and 50.6%. See how easy that was? Now, the second question is saying, can we reject the population percentage of 23.3? And I hope you guys can see right away, we can reject it because 23.3 is not between 36.6 and 50.6. So yes, we reject it. Not in the interval, not plausible that the graduation rate is 23.3%. Wow, you guys thought this was going to be so hard. All right, next question. So far we have not really used StatCrunch or the calculator, right? So question 2. A statistics instructor randomly selects 4 bags of oranges, each bag labeled 10 pounds, and weighs the bags. The weight is 9.2, 9.5, 9.2, and 9.3. Assume that the distribution of weights is normal. Find a 95% confidence interval for the mean weight of the bags of oranges. Okay, use technology. So I'm going to do this first with the calculator, and then I'm going to do it with StatCrunch. We've got 9.2, 9.5, 9.2, and 9.3. Okay, let's use our calculator first. So in this case, we have to build a list. So statistics, edit. If you have information in these lists already, go up to L2 and clear them. Enter. Okay, and L1, clear your list out. This is from some previous thing that we did. And type in your current data, which is 9.2, 9.5, 9.2, and 9.3. So we have our data on a list. Now you go to Stat, and we want to go over to Test. Select number 8, T-Test. And this time we're inputting data, not stats. Enter. And it's going to take the data from list 1. So keep going down. Leave frequency is 1. Make sure your confidence level says 0.95 and calculate. Give the calculator a little time to work. Capture your screen. Copy it and place it into the notes here, okay? All right, now let's do this with StatCrunch, okay? Both programs. So in StatCrunch, we would enter the data in a table right here. Need my keyboard. I've got 9.2, 9.5, 9.2, and 9.3. Notice that the title of this group is VARS1. You can name it anything you want. You can rename it if you want. It's up to you. If not, I'm just going to leave it as VARS1, okay? So to compute here with data, stat, tstat, one sample with data. Not with summary this time, but with data. Select VARS1. That's where we have our data. Confidence level 95%. And compute it. And here we have what should be exactly the same um, reading as we got on the calculator. We'll check them out. Let's go ahead and paste it here. Drag this over a little bit. All right, here we go. So let's see what we have. We've got, they want this to 3 nearest thousand, so 3 decimal places. So we've got 9.075 and 9.525. Round this up to 3 decimal places, 9.075, 9.525. By the way, notice the calculator also calculates the mean and standard deviation if you needed that information. We don't. Now, when you write the answer here, remember you're always using the word population. So we are 95% confidence that the population mean is between, what is it, 9.075 and 9.525. Now, the question continues, does the interval capture 10 pounds? So 10 pounds is not between 9.05, sorry, between 9.75 and 9.525. Okay, so no, it does not capture, reject the claim of 10 pounds because 10 is not in the interval. Question 3. The weights of 4 randomly chosen bags of horse carrots, each bag labeled 20 pounds, were 20.4, 19.5, 20.8, and 20 pounds. So we're going to be expected to calculate here. Your choice whether you want to use your calculator or StatCrunch. I'm going to go ahead and use StatCrunch. Maybe I can do both, yeah? Just this time I'm going to do both and check them. All right, let's do the calculator one first. So calculator, I need to edit my list. All right, so stat, edit. So I'm going to clear this list out and put in my new list. 20.4, 19.5, 20.8, and 20.0. And then stat again, test, stat, test, number 8. Everything is the same, list 1. So scroll down, scroll down, scroll down. Calculate, yay, here we go. Give it a minute, the calculator has to work. And it's giving us between 19.29 and 20.06. We're going to go ahead and capture the screen. And then I also want to do this once again in StatCrunch to make sure you guys can also do this in StatCrunch if you want to. So I'm going to go ahead and add numbers in here. Keyboard 20.4. Um, 19.5. 20.8 and 20.0. Okay, close this. Stat, tstat, one sample with data. Vars 1 is the data, confidence level 0.95, compute. Wow. So, I forgot what to do here. I got to snip this, yeah? This one doesn't move over like the last one did. We have to snip it and place this in our notes so we can see it. All right, so here we go. We can see the reading for both is lower limit 19.29, upper limit 21.05. They're asking for this one in terms of careful how many decimal places, be careful, nearest hundred, so 2 decimal places. Again, 95% confident about the population, 19.29 and 20.06. Can you reject the population mean of 20 pounds? So 20 pounds is between 19.29 and 21.06. So we can't reject it. We have to accept it. Do not reject. Okay, so 2 choices, but do not reject. Do not reject because since 20 pound is in the interval, this one says not, so we can't choose that one. It is plausible that the population mean is 20 pounds. Question 4, a random sample of 10 colleges was taken. A 95% confidence interval for the mean admission rate was 52.8% and 75.0%. That's the lower and upper limit. The rates of admission were normally distributed. Which of the following statements is correct interpretation of the confidence level for which the correct interpretation of the confidence interval? A, we are confident that the mean admission rate is between 52.8 and 75.0. So that's an interval. So statement A correctly interprets the correct interval. Yeah, this one has a statement A correctly interprets the confidence interval, and then in about 95% of all colleges, the confidence interval will contain admission rate. So this one actually gives the confidence level and statement. So A would be the correct choice here. All right, kind of a straightforward problem here. A hamburger chain sells large hamburgers. When we take the sample of 25 hamburgers and weigh them, we find that the mean is 0.57 pounds and the standard deviation is 0.1 pound. Okay, that's shown on the printout here. They gave us this. They tell us a technology input for the calculating confidence interval requires a sample size, a sample mean, and a sample standard deviation. State how you would fill in these numbers. So they're asking you to how you'd fill it in on a calculator. Sample mean, sample size here is 25 hamburgers. Okay, so 25. The sample mean is 0.57 and the standard deviation is 0.1. And how would you state the confidence? Remember, you're looking for population. We are 95% confident that the population mean is between, and they're asking for all 4 of the digits, yeah? Round to 4 decimal places. So 0.5287 and 610.6113. No calculation here, eh? They gave us the printout. Yes, I believe this question is also a similar type problem. Question 5. A fast food chain sells drinks that they call huge. When we take 36 drinks and weigh them, we find that the mean is 35 ounces with a standard deviation of 2.4 ounces. So they gave us a TI-84 printout here fill in the blanks below. So X, again, as a reminder, refers to X bar refers to the sample mean. Okay. And S of X, SX refers to the standard deviation, and the sample size is given as 36 drinks. Write the confidence interval. Do not round. We're looking for population, 95% confident that the population mean is between 34.688 and 36.312 from the printout here, okay? From the printout. All right, question 7. Ooh. So a sample, 1 second here. Kind of lost my page on the notes. All right, here we go. A random sample of 14 men's resting pulse rate shows a mean of 70.6 beat and a standard deviation of 17.8. Use the table to complete parts A, B, and C below. So they gave us a table below here that we're not going to use because they want us to calculate the confidence level from scratch. Instead, we're going to go to the calculator and put in these numbers. FYI, do not use the table. Use table. Use stat, crunch, or calculator. Okay, tables are kind of redundant at this point. All right, so let's see. The sample size is 14. Mean is 70.6. Standard deviation is 17.8. Let's do the calculator first. Stat. Test. Okay. I think I selected the wrong test. Let's do this again. Stat. Test. Number 8. I selected the wrong one. Yeah. All right, so now we're using stats, not data. Okay. And we're going to input the X value, the mean as 70.6, the standard deviation as 17.8, the sample size is 14, confidence level 0.95, enter. So we've got 60.323 and 80.877, okay? Capture this. I'm also going to do this in StatCrunch one more time for those of you who are still trying to follow me. Okay, paste this. And then let's use StatCrunch as well, okay? So this time we need stat, tstat, one sample with summary, okay? Sample mean is 14. Sample standard deviation. Oh, I'm sample. So sample mean is 70.6. Standard deviation is 17.8. And the sample size is 14. 95% confidence interval, compute, And we're going to copy this over as well and make sure that we have the same value for both. Okay. All right, so here we go. In both cases, we can see that the lower limit is 60.323, sorry, and the standard and the upper limit is 80.877. We're writing the 95% confidence interval about the population, so B. We're 95, sorry, not C, B, 95% confidence, the population. And they want this to the nearest tenth, so 1 decimal place only. 60.3 to 80.9. 60.3 to 80.9. Now, the problem continues. Find a 90% confidence interval. Instead of 95% confidence interval, find a 90% confidence interval for the same data. Okay, so let's go back to the StatCrunch program, options, and we're going to edit it, and for the confidence level, we're going to change it to 90%. Okay, so 90%. And compute it, and copy it and paste it. So a 90% confidence interval. Okay, it's different, and we're also going to do this with the TI-84 data. We're going to go back and edit the list that we had for the test, number 8. And the only thing we're going to change is the confidence level to 90%. And this should give the same numbers, yes? 95% confidence, it will give exactly the same number, yes. Copy, paste it. All right, so here we go. Again, we can write the confidence interval here. So we're 90% confidence that the population mean A, 1 decimal place between 62.2 and 79.0. 62.2 and 79.0. Now, which interval is wider? So let's subtract here. We've got 80.9 minus 60.3 and 79 minus 62.2. Subtract the two just to see which one is wider. I already know the answer because the answer is kind of straightforward. 80.9 minus 60.3 is 20.6. And 79 minus 62.2 is 16.8. So as expected, the 95% confidence interval is wider. Okay, it will always be wider. The reason that it's wider is what's important. We would use a bigger test value, which creates a wider interval. Okay, a bigger test value. And don't worry too much about the explanation for this, but the T star is, if you were doing this from scratch, what you would need. But the fact that if you had a 95%, the higher your confidence interval is, the larger that T star number would be. Okay, but we don't do this manually, so don't worry too much about it, okay? All right, moving on. Question, remember, don't use this table here, okay? Don't use that table. All right, question 9, that what we're at? Oh, I'm sorry, question 8. Question 8. Okay. The weights of 4 randomly independent selected bags of potatoes labeled 20 pounds, 20, 21, 28.8, and 20.2. Assume normally, find the confidence interval. So sample is 4, 20.7, 21.1, 20.8, 21.2. I'm just going to use StatCrunch for this, okay? Edit my StatCrunch table. So 20.7, 21.1, 20.8 is already there, and 21.2. Compute the confidence interval at 95%, I think. Yeah. T-stat, one sample with data, variance 1, confidence interval 95, compute. And we're getting this wonderful confidence interval of 20.57 and 21.32. You guys can also compute this with your calculator if you want, okay? No worries. So the confidence interval to nearest 100, 2 decimal place is 20.57. And 21.33. Okay, we are find a 95% confidence interval. Does the interval capture 20 pounds? It does not. Okay, 20.5, the lower limit is at 20.5 pounds. So it does not capture, there's 2 that have does not C and D. So there is enough evidence to reject a mean of 20 pounds. It is not plausible that the population mean is 20 pounds, okay? I think question 9 is the last one for this. You guys can probably answer this. This came from the notes. Which of the following is an appropriate interpretation of the confidence interval? Which one do you think? Look for population, a range of plausible values for the population parameter, okay? All right, that ends 9.3. We're going to stop and continue with 9.4 in another video. So questions 1 to 9 are on from 9.3.